JAMon is an open source API that allows you to see what's happening inside your program. It consists of start, stop, and add methods. The start and stop methods allow you to time your program much like a stopwatch would. And the add method allows you to track non-performance aspects of your system, like the number of bytes sent down a pipe or the number of exceptions your application throws. Here is sample code showing how start and stop work. This monitor is timing how long a method takes to run by passing in the method name as a label to the stopwatch. This label is used as a key in a hash map and so should be relatively unique. Every time JAMon is passed the same label, it aggregates the following statistics that it gathers. Hits, which in this case would be the number of times the method was called. Average is the average time of invocation. Min is the fastest invocation. Max is the slowest invocation. Total is the total time. And active is actually how many of this method are currently running. The last value is how long did the last invocation take, and the last accessed is a date which represents when the invocation was last executed. All of this information and more is programmatically accessible and also viewable via the JAMon War reports. The fact that a label is simply a string allows you to monitor many aspects of your program. Here are some examples. Page names, which lets you track performance of all your web pages. SQL queries, which lets you track performance of your database subsystem. In fact, JAMon can monitor interfaces, page hits, SQL and JDBC calls without any code changes on your part. You can also get creative with your strings and append usernames or a date to the end of them, as you can see in these examples. Being as JAMon is stored in a hash map, you don't want the keys to be too unique, however. For example, you wouldn't want to append the exact time to the second or millisecond, as this example shows. The add method lets you monitor non-performance aspects of your system, such as file I/O. In this example, we are indicating that we have read a 15 megabyte file. The MB passed to the add method represents the units associated with the label. This example shows how we can use JAMon to track the number of exceptions your application throws. We simply pass in the number 1 to the add method to count the number of exceptions. The label could also have more specific exception information. For example, it could contain a specific application or SQL exception. In fact, JAMon can automatically track exceptions thrown by servlets, SQL calls, and methods. Tracking aggregate information is useful. However, JAMon also allows you to associate detailed information with each monitor. Other tools call this concept context or payload. This example shows how the JAMon add method, in addition to taking a string, can also take a key. The key can be passed in detailed information that can be accessed via the JAMon API or viewed via the JAMon War. In this case, we are passing in the exceptions stack trace. It will now be viewable with the JAMon webpage. JAMon allows you to register listeners that are automatically called at certain points in a monitor's lifecycle. This allows you to take action based on what's happening inside your application. Your registered listeners can be called automatically every time there's a new value, min, max, or max active. There are some pre-installed listeners that let you look at the details such as the stack traces that we mentioned in the previous slide. JAMon comes with configurable monitoring capabilities that don't require code changes on your part. For example, HTTP monitoring tracks page hits, execution times, bytes sent, status codes, exceptions, and more. JDBC SQL monitoring tracks SQL performance, exceptions, as well as method invocations on connections, statements, prepared statements, callable statements, and result sets. EJA monitoring tracks method execution times and exceptions. Look on the internet and you will see a number of ways people have used JAMon with AOP. Also, any Java interface can easily be monitored using JAMon interface monitoring to track execution times and exceptions. Log4j monitoring allows you to see statistics like how often fatal, error, debug, etc. are called. You can also use JAMon listeners to tail the Log4j log and view it via the JAMon War. And finally, there is operating system monitoring. This allows you to make calls to JAMon from your Unix Linux scripts. Go to JAMonapi.com to learn more. Thanks and happy monitoring.